Good afternoon, Year 6, and welcome to your second science lesson. So last week we looked at how light travels and that it travels in straight lines and that it can be deflected if there's an object that it can't travel through, such as an apple or a black dark object. So today we're going to answer the question, what happens when light hits an object? So a bit of an extension because towards the end of the science lesson last week we did put an object in the middle of that diagram. So how is light reflected? So when light hits an object that it cannot travel through, so an object that's not see-through, yeah, transparent, okay, it is reflected, okay? So it bounces off the surface and changes direction of that ray of light. So you can see in the diagram here, this is your incident ray. This just means the original ray of light, okay, coming from your torch. It hits this object, for example, a wall, and then is reflected back in a different direction. So if this wall wasn't here, that ray of light would just continue to travel in a straight line until it hit something, okay, to cause it to change direction. So all objects reflect light. Smooth and shiny surfaces reflect all the rays of light at the same angle rather than scattering the rays of light like rough, dull surfaces. So if you had a rough, dull surface, okay, the rays of light would scatter in different directions. But if it's a smooth, shiny surface, it stays in one direction. So we could assume on this diagram that this reflected ray is just one ray, so it's a smooth, shiny surface it is being reflected off, okay? So the light ray hits the mirror or any other object, okay, and it's described as the incident ray, which then bounces off and becomes the reflectant ray. So when rays of light reflect, there's something called the law of reflection that they have to stick by, okay, and that is the angle of incidence always equals the angle of reflection. You can see here, you've got your two angles. So if you drew a line down the middle, like you can see on the dot, this angle here is equal to this angle here. They are the same. If you measured them with a protractor, my maths group, we've been looking at that. If you measured them with a protractor, they would be equal. Bonus points if you can tell me if it's an acute, obtuse, reflex, or right-angled angle, my maths class. The red dashed line is the normal line, so that's where it would have gone, okay? So it's drawn at a right angle. So you can see, look, here's your clue, guys. This is your right angles, and it's drawn at a right angle to the object. So this is your object here, this wall, shall we say, or mirror, you could call it. All right. So the angle of incidence is between the normal line and the incident ray of light. So here's your normal line, and here's your incidence light, and there's your incidence angle. And then we've got your reflected ray, your normal line, and then you've got your angle of reflection as well. So you can try this at home now. You might not have a mirror or anything to stand it up on, but you could just use an object. And if you've got a torch or anything that will emit light, this would be a really good experiment to do, okay? So you could just get a grown-up to hold that object in one underneath a piece of white paper. Shine your object, shine your incident ray onto that object and draw lines where it's going to hit the object, okay? And then you should end up with a diagram that looks like this, and it also will look like the one previously that we've just looked at. I would love to see those. If you could upload a photo, that would be great. Don't worry if you can't do it, then if you go on to BBC Bite Size Science, you can always watch it being done as well. So, key tip here, perpendicular, remember it's a posh word for right angle. Remember our right angle is our 90-degree angle in here, yeah, 90 degrees, just to remind you, okay. So to draw your diagram, remember you need a dashed line, which is your normal line, which should create right angles at the mirror, okay, you can see here and here. Okay, and then you've got your incidence ray and then your reflection ray. Okay, yours might have reflected in a different direction, that's okay. Okay, now I know you won't have a protractor to measure the angle, so don't worry. Do you think it looks the same? If it doesn't look the same, there might be a bit of a problem there. Okay, so what you are going to do. Greens, you're going to use words and diagrams to explain what is meant by reflection. So you could use the diagrams that we have gone through, label them and explain what they show. So remember, the diagrams on our lesson have an explanation next to them as well. That's what you need to do. It could just be simple sentences or bullet points underneath. Blues, you're going to draw a diagram of the experiment that you carried out. You might not have carried the experiment out, but could you predict how it would happen and could you draw what you would do? Okay, could you maybe pick a different object or maybe think of a different light source? Reds, you're going to again draw a diagram, label the angles of incidence and reflection, and if you do have a protractor at home, you can measure them and say what you notice. If you don't have a protractor, you should say what they should be. Okay, and then there's an extra challenge for anybody who finishes in under an hour. Okay. Fair test. Does light intensity change when a torch is shone through a longer tube lined with tin foil? So, if you've been shining, has anyone ever shined a torch through maybe a kitchen roll tube? Okay, if you do that, and then if you line the kitchen roll tube with tin foil, grown-ups might have to help, see what happens to the light, see what it does, and then explain your answer. Okay, you could maybe make a prediction before you do the experiment and then write up your results if you have time. Enjoy year 6.